So the first thing we're going to do is find out how much chlorine is in this compound. So we know carbon is 10.4%, sulfur is 27.8 grams or percent, and then chlorine, to find chlorine, we're going to add 10.4 and 27.8, which gives us 38.2. We're going to subtract that from 38.2, no, that from 100, and we're going to get 61.8%. But we could treat each of these as grams. So what we're really saying is that 10.4 grams, 27.8 grams, and 61.8 grams. So now we're going to divide this by its molecular mass, and the molecular mass of carbon is 12.011. This one is 30. The molecular mass of sulfur is 32.066, and the molecular mass of chlorine is 35.453. So now let's do carbon down here. We are going to get 0.8658729498. Sulfur is going to be right here. So there we go. And sulfur is going to be 0.8669618911. And chlorine is going to be down here at 1.74315297. Okay, so that's what we have so far. And now we're going to divide out by the smallest number here, which is going to be this one. So you're going to divide this by itself. 729498, and you're going to get 1. And you're going to divide here, 6 by the same number, sorry. 8729498. Same number, 498, and for this one you're going to get about 1, close enough to 1, and here you're going to get about 2. So from that you're going to see that your ratio is going to be a 1 to 1 to 2, meaning that there's going to be 1 carbon, 1 sulfur, and 2 chloride. So we're going to write that like this. And that is the empirical formula for the first part of the question. So there we go. And now there's the second part of the question. And it asks if a compound with molar mass 84 grams per mole has the empirical formula CH2, how many atoms are in one molecule of this compound? So first we're going to start out by writing out the molecular masses of each atom. So there's carbon and there's hydrogen. And now there's only one atom of carbon, and its molecular mass is 12.011. You're going to multiply it by 1. But there are 2 hydrogens, and hydrogen is 1.008. So we're going to multiply 1 times 12.011, and we're going to get 12.011. And 2 times 1.008, we're going to get 2.016. So we're going to add that together. 14.026. So now this is the weight of the empirical formula. So what we're going to do now is we're going to divide 84 by 14. So let's see. 84 divided by 14.026. And we get 5.988877798, which is about 6. So that means that you're going to multiply each of these by 6. So if the ratio is a 1 to 2 ratio, you're going to multiply this by 6, you're going to multiply this by 6. Meaning your new ratio would be a 6 to 12. So there are going to be 6 carbons and there are going to be 12 hydrogens. And the question is asking how many atoms are in one molecule of this compound, and because there are 6 carbon and 12 hydrogen, you're just going to add 6 plus 12, and you are going to get 18 atoms in one molecule of this compound. So there we go. That's the second question. Well, the second part.